minus 2 times, oh, this should be minus, rather. Minus 2 times 1 is minus 2, minus 2 times minus I is minus 2i, 2 times 1, 2i times 1 is 2i, 2i times minus I, and so these part cancel. Then I squared is negative 1. And then that's in the numerator. And then we divide it by the denominator, which is a squared plus b squared, which is 2. And so this is working out to be minus 4 over 2. So we have it's equal to, this part here is minus and minus. I squared is negative 1. Negative 1 times negative 2 is 2. That's 4i divided by 2. 4i divided by 2 is 2i. That's option D. Question 2 is asking us to express the complex number in this particular form. In order to do that, what we need to do now then is to find the argument and the, so we need to find the argument, and we also need to find the modulus of the complex number r. R is going to be equal to the square root of 3 squared plus 1 squared, which is 3 plus 1 square rooted, which works out to be 2. And then we need to find our argument, the argument of c. I'm going to call the argument of c theta. And the argument of z is just equal to the tan inverse of y over x, which is 1 divided by the root of 3. That's pi by 6. That's option D. Question 3 now, it's saying, which of the following sketch of the locus of the point is represented by the complex number given by the modulus of z minus 5i is equal to 3. So what this is saying is that this is really z minus, we can put this in the form z, since it has a minus right here, we're going to put a plus 5i, and that's equal to 3. And so what we actually have is that the center is 0, negative 5, with a radius of 3. Well, the center is 0, 5, rather, not negative 5. 0, 5, and a radius of 3. So look for which one has a center of 0, 5, and a radius of 3. That seems to be option D. All right, now we're here where it is quite clear. Question 4. Question 4 is asking us to find the square root of 3 minus 4i. To find the square root of 3 minus 4i, let's say the square root of 3 minus 4i is equal to a. Then what we know then is that a squared is equal to 3 minus 4i. So what we're going to do then is check which of these answers When we square it, it's going to give us 3 minus 4i. All right, so I know it's option C, and so just to justify, we have 2 minus I. When we square 2 minus I, what we're getting is going to be equal to 4 minus, that looks like 4i plus I square plus I square. And so that works out to be equal to 4 plus I square. 4 plus I square, well, I square is minus 1, so this works out to be 3 minus 4i. 3 minus 4i. And so option C is the answer. Easy question. Question 5. It says that the modulus, well, it says that this is too small for my eyes right now. Yeah, that looks better. It says that Z bar is the conjugate of Z. Which of the following is true? I is true. How do we know that? Yes, the norm of Z, or the length of Z, is going to be equal to the length of its conjugate. That's always true. All right. Now they're saying, is the argument of Z equal to the argument of Z bar? No, this one is not true. And so anything with option 2 is out. How do we know that it's not true? Because the angle for the argument is not, it's never going to be in the same quadrant, right? And so therefore, option 2 can never be true. So the answer is B. And we move on to question 6. Question 6 asks us to find y is equal to tan inverse of 2x. But look at this question. It doesn't ask for dy by dx. It asks dx by dy. Dx by dy, that's not dy by dx. Important to know that. Well, first thing I want to tell you is that dx by dy is 1 over dy by dx. So you can find dy by dx first. So find dy by dx, and when you differentiate tan inverse of 2x, you get 1 over 1 plus 2x all squared, which is 1 plus 4x squared times 2. And you put a 2. Put a 2. So that's dy by dx. So therefore, dx by dy would just be the reciprocal of this. However, the reciprocal is not there. Let's have a look at this. Y is tan inverse of 2x. So that's option C. This should actually read dy dx, not dx dy. Dy dx. Because think about it. If we were to take the tan off both sides, we would get that tan y is equal to 2x. And then we could differentiate both sides with respect to y. Differentiating both sides with respect to y, we need x the subject. So I'd see that x is equal to tan y over 2. And then I could differentiate with respect to y to get dx dy. And dx dy is equal to, when we differentiate tan, we get sec squared. Sec square y over 2, and that option is not there. And so clearly Because that option is not there, then there's no answer for dx by dy, because sec squared is 1 plus tan, right? Sec squared is 1 plus tan, and tan y right here is 2x. And so there's no option right there. So this should have been dy dx. That's what this question should have been asking. Question 7. Question 7 gives us e to the x plus y minus x, and that's equal to 0, and find dy dx. So to find dy by dx, well, this first and foremost is a product. It's e to the x times e to the y. So we keep the first, then differentiate the second, plus keep the second, then differentiate the first, keep the first, differentiate the second. So I need to have a y prime right here, plus keep the second times the differential of the first. When I differentiate x, I get 1. That's equal to 0. And so now I just need to make y prime the subject. So when I bring everything over, what I'm going to get is that y prime is going to be equal to 1 minus e to the x plus y divided by e to the x plus y. Very easy question. That's option B. All right, now to go to question 8. Question 8 says that a bacteria present in a culture is modeled by y is equal to y naught e to the kt, where k is greater than 0. Y is the population after t hours, and y naught is the initial population. The rate of growth c when t is equal to 5 is given by, so right here we have c is equal to, c is the differential, so c is equal to dy by dt. That's what they're telling us, the rate of growth. C is dy by dt. And so in order to find dy by dt, well, we differentiate this right here. So we bring down the power is k, and so we're going to get k y naught e to the kt, and in this case t is equal to 5, so we'll get 5k. That looks like option D. All right, question 9. Question 9 is saying we want to find the derivative of the function y is equal to ln cosine x over the sine of x. So in order to find the derivative of ln cosine x over sine x, well, first what you're going to have to do is call this u. So if y is equal to ln u, y is equal to ln u, well, first and foremost, in this case, we have ln a over b. But what do we know about log functions? We know that log functions, we can write this as ln a minus ln b. That's a rule of logarithm. So since that's a rule of logarithm, we can apply that right here to this question. And so in this case, what we actually have is ln the cosine of x. So we have ln the cosine of x, and we're subtracting ln sine x. So now we can then find dy by dx. So dy by dx is y prime is equal to When we differentiate ln a function of x, we get 1 over the function of x. So we get 1 over cos x times the derivative of cosine x. Now the derivative of cosine x, when you differentiate cos, you get minus sine. So I'm just going to put sine right here. Sine x, and put a minus. That's a minus in front of the sine x. Then minus, when I differentiate ln sine x, I'm going to get 1 over sine x times, when I differentiate sine x, I get cosine x. So in the numerator, it's going to be cos x. So the numerator is cosine x. So that's y prime. Y prime is equal to minus sine x minus cos x over cos x sine x. Now, when you look at these options, nothing look like this, right? So what you're then gonna have to do is to join these two. And so when you join them, right, so the LCM is gonna be cosine x times sine x. So we join them to have cosine x sine x. And then we can see that cos x into cos x goes sine x times, and sine x times sine x is sine square. So we get minus sine square x minus sine square x. And then sine into sine leave cos, and so we get minus cos square x. We're almost finished. This question was a little bit longer. Now, if you were to factor out the minus from this, then what you would get is that this part right here, let's continue it over here, put it in black. This part right here is minus 1 over cos x sine x. That's the final answer. Minus 1 cos x over sine x. Easy, soft. Now let's look at which option that is. Now, first and foremost, when you see cos x sine x, the identity should come to your mind. If I were to somehow put 2 right here, 2 cos x sine x is sine 2x. And if I were to put 2 in the numerator, then what I'm getting is, oh, and I don't even need to put 2. The option is right there. No worries. The option is there. We have minus 1 over cos x sine x. That is option B. Option B right here, this sec x is 1 over cos x, and this cosec x is 1 over sine x. You multiply them, that's what you get. So the option is B. So that's the derivative. Easy question, that's question 9. Question 10. Question 10 says, given that f of x is equal to ln 3x squared, then what is f prime of minus 2? Well, this is f of x, and so f prime is going to be equal to, when you differentiate ln 3x squared, right, you get 1 over 3x squared times the derivative of 3x squared, which is 6x over 3x squared. And so that works out to be 6 over 3 is 2, and then x over x squared. X over x squared is just x. And so what we get is, now f prime of negative 2 then is going to be 2 over negative 2. 2 over negative 2, and 2 over negative 2 is minus 1. So that's the answer, which is option D. That's question 10. All right, that's question 10. Now we go to question 11. Question 11 says, what is the integral of 4 times e to the 2x minus 1? All right, so we're integrating. So when you integrate exponentials, we just divide by the differential of what's in the power. So that works out to be, we integrate it, we're going to get 4 e to the 2x minus 1, then it's going to be divided by 2. We divide it by 2 plus some constant. And 4 over 2, that's just 2. So it works out to be 2 e to the 2x minus 1 plus c. So that's a very easy question. This has to be like the easiest question on the paper. That's option D. Very easy. Soft, the capital T. And so now we need to now find what is the argument of the complex number z. Find the argument of the complex number z, which is equal to 1/2 plus I times root 3 over 2. To find the complex number z, well, if z is equal to a plus bi, then the argument of z, I'm going to call the argument theta. The argument of z, I'm calling it theta, is tan inverse of b over a. So the argument of z is the tan inverse of root 3 over 2 divided by 1/2. So it's tan inverse of root 3 over 2 divided by 1/2. Tan inverse of root 3 over 2 divided by 1/2. So root 3 over 2 divided by 1/2. That's tan inverse of root 3. And tan inverse of root 3 is pi by 3. Easy, soft. Question 14. Question 14 is asking us, it is saying if f is such that dou f by dou x is equal to that, and dou f by dou y is equal to this, then which of the following is true? Now, this question has been repeated for many years. The option answer is B. How did we work it out? What I said was to try which of these would be f of x. And so you're going to try f of x as this one, and then you're going to find dou f by dou y and dou f by dou x. That's option B. Easy question. Question 15, it says sec square x is equal to 1 plus tan square x. And then it wants us to evaluate the integral of tan square x divided by 4. Now the integral of tan square x divided by 4 is going to be equal to the integral from 0 to pi. First of all, tan square x is going to be equal to sec square x minus 1. So it's the integral of sec square x minus 1 divided by 4. That's the integral of tan square x. Now this part right here, we can break it up into two different integrals. We can break it up as the integral from 0 to pi of sec square x over 4. Even Asani. I don't know what's happening with everyone's Wi-Fi. I don't know if it is mine, but there's been about 4 or 5 persons here and they just keep on disappearing.
Really?
Yeah, I don't know what's happening. Maybe it's my Wi-Fi.
Tomorrow is the starting of my examination.
Tomorrow's the start?
Yes, sir.
Which exam you have tomorrow?
Morning, church studies.
Carib studies, that's easy, man. You finish study?
Well, you can say that. Just reviewing my past papers.
Okay, that's very good. All right, make sure you get distinction, you know.
Hopefully, sir. I'm
All
going
right.
to ask the teacher again for the SBA grade.
Who is it? Who is a Carib teacher?
Yes, Barry Smith.
Oh, and she don't give you SBA grade yet?
She gave us an answer, but we keep on getting corrections. So I don't know what we did this time,
Oh, you don't know your final SBA grade then?
No, sir.
Okay. All right, so find that out. It's very important that if you can text her now would be good. It's always good to go in the exam knowing like your grade before you do the test.
Yes, sir.
Find out your grade from her so that it's always good to go in the exam knowing your grade. Right? You never want to go in a test and you don't know where you are.
Yes, sir.
All right. So yeah, so we started 2017 paper and we're at
20,
question 15.
is this
27.
2015
This is 2017.
or 2017?
Yeah.
We did 2015 already, right?
Yeah, we did
And
2015 and 16 last week.
oh, right. I
So
forgot.
we're getting closer and closer to 2019.
We're
Yeah,
gonna
and
do
in
one
20,
paper now.
repeat?
We're gonna do one paper now.
Yeah.
Okay.
And so it's 2018, as I was mentioning to the young lady that was here, there is a lot of new questions that when she was looking at it, this for 2018, they gave a couple of new questions. For example, the first question was new. They asked to express in the form a plus bi, but all we had to do was rationalize.
Oh, division of complex numbers. Okay.
Yeah, so that's was
Now,
division of complex number. That's a new question, question 1. Another new question was question 6. There's an error in the question right here. So question 6, I'm sure the invigilator would have mentioned it. Look what the question was asking for.
wow. Right
dx
in
by
there.
Yeah, sometimes it happens like sometimes they're trying to change the question, but in changing the question, they didn't change the answer. So they wanted it to be a new question,
dy
but
by dx implicit.
yeah, because it asks dx by dy. As I was showing her, dx by dy would have been, you'd have to do this. You'd have to say, if y is equal to tan inverse 2x, then if you take the tan of both sides, so from right here, take the tan of both sides, you get that tan y is equal to the tan of tan inverse, the inverse cancel the tan, and so you're left back with 2x. Then you divide, repeat?
I can do this question.
Yeah, easy. Then we divide by 2, and so we get x is tan y over 2. And then now to find dx dy, we differentiate x with respect to y. And the differential of tan y is sec square y over 2. So that would be dx dy. However, this option is not there because they didn't change the options. And so clearly it's dy dx the question should have been. So they wanted to give a new question, but they didn't change the answer. Option 7 is a big repeat question. Option 8 is a repeat question. Option 9 is a new question now. So this is also another new question. They said, what is the derivative of ln cosine x over sine x? And as I was showing her, it's very difficult to differentiate when you have a quotient. And so I was telling her to use rule of log to say ln A minus ln B. So it's a ln
The ln
cosine
of cosine is 1 over cosine times the derivative of cosine, which is negative sine,
exactly right here,
minus
negative sine x.
okay. And the ln of sine x is 1 over sine x times the derivative of sine x, which is cos x.
Yes. So we have minus cos x over sine x. And so all you have to do now is to join it as one fraction. And so we get minus sine square x minus cos square x. So minus sine square x minus cos square x is minus 1. And so we get
Is
minus,
minus sine x minus sine square x minus cosine square x.
that's
Over
minus
cos.
1.
You get minus 1 too.
Because if you factor out the minus 1,
Oh, fuck.
you get sine
Minus.
square plus cos square. You get minus,
Oh, yeah.
and
We
so
get
that's
to
how you
yes,
get minus 1. Yeah. And then this part now, I can write minus 1 as, I can always write minus 1 as minus 1 times 1. And then this minus 1 over cos x is
would have
minus
been
sec x.
minus sec x.
And then the 1 over sine x is cosec
Cos
x.
sec x. Okay, okay.
And then she disappeared. And we looked at question 10. That's a repeat question. No, this is a new question. Yep. So usually it is something like ln x to the 1/3 or something like that. This time they change it to 3x squared.
Okay.
Subtle changes, but it's nothing.
Same principle.
Yeah, same principle. So you just want
Going
to
back to the
see.
argument question, sir. Number 5. Number 5.
Yeah.
The modulus of the conjugate is equal to the complex number, right?
Yes, it's equal to the modulus of the complex number.
And if you multiply the complex number times its conjugate, you're gonna get the real number.
Yes.
Okay.
All right.
And number
And
7
question
now.
11. Number 7. So
Yes,
this
sir.
is a repeat question. 7 is a repeat question.
Alright, so to do this now, just break e to the x plus y into e to the x times e to the y minus, oh, and then you just take the product rule. You just use
Yes,
product
use
rule.
product rule. Yeah.
So if you differentiate e to the y, you're gonna get dy, you're gonna get y prime times e to the y.
Yes, which is right here. Y prime times e to the y.
And it's gonna be e to the x times y prime e to the y plus e to the y times e to the x
Yes,
minus 1 equals 0.
equals
Okay.
0. And then you make y prime the subject. You make dy dx the subject.
Okay.
Easy question.
So
Soft. Capital T. This question is another big repeat question. It always seems to come 1 minus
1
sine
minus
squared,
sine squared is cos square
cos
x.
squared, and then 1 over
1
cos
over cos
squared,
is secant square
and the
x
integral of
of
secant
secant
square
square x is tan x. Yeah.
tan x. Big repeat question. That's question 11.
I know I'm going to show this exam, your maths exam.
Yes, definitely. Which exam you have next week?
Well, the 21st, I don't remember which day is the 21st. I have unit 2 chem.
Have unit 2 chemistry? That's the 21st. That is next week, Wednesday.
Oh, yes, sir.
Okay. Oh, okay. I won't get to see it then. I'm coming to school on Thursday.
On Thursday for
Oh, we have department meeting.
oh, okay.
Yeah, I thought you had an exam on Thursday.
No, sir.
All right. This is another new question now, but this is the easiest new question
Oh,
ever.
if you
Question 4.
integrate in an exponent now, then you divide by the derivative of the power that is raised
Yes.
to.
So let's divide by 2. So let's divide this by 2. Easy question. Very easy.
Then if you differentiate 2x minus when you get 2, so you divide all of that exponent function by 2.
Yeah.
Okay, I get a plus c.
And then question 13 is a repeat question,
Yep. So
which was 5 by 3 soft. Question 14 is a repeat question.
yes, sir. I would like to know how to do this one again, the partial
Question
derivative.
14.
Yes,
All
sir.
right. So I'm not going to show you the long way. The easy way I said to do it was you're going to try the options right here. So what you're going to do is it says which of the following is true. You're going to, let's say you start with saying f of xy is e to the x times sine of x plus y. If you were to differentiate this with respect to y, so find the partial derivative with respect to y, when you differentiate sine x plus y, you get cos, but cos is not right here, right? And so
Oh,
clearly option A would be,
if you're
oh,
gonna say dou f by dou y,
yes, dou f by dou y.
it's
So
gonna
dou
be
f
e
by
to the x cos of x plus
x
y.
plus y, yes. So since this one with sine is not going to give us,
Oh,
since we know when we differentiate it, we should get sine. And so clearly option A and option C out. Why is option C out? Because same thing, when you differentiate the sign, you're supposed to get cos. So option C is also out. So you just need to check between option B and option D. So check option B now. When you differentiate cos, you get minus sine x. And then the e to the x is
oh,
constant.
okay.
All right. And so then now, since this part is correct, you need to check now if dou f by dou x is correct. So then now dou f by dou x, you're gonna have to use product rule. So use product rule, you're gonna get dou f by dou x, or call it, let's say fx. Fx would be equal to, keep the first, which would be e to the x, differentiate the second, we differentiate cosine,
We get
we
minus
differentiate
the
the,
sine.
so we get minus the sine of x plus y plus, then we keep the second, keeping the
Plus
second
the
part, which is
sine plus the
plus
cosine of x plus y.
cosine of x plus y times the differential of the first. But then we differentiate e to the x, we just get back e
E
to
to
the
the
x.
x.
Yeah. And so then from this answer right here, all we have to do is factor out e to the
Factor
x.
e to the x.
And we see that option B is indeed
B
true.
is an oh.
So that's why that's the easy way to do it. There's a harder way to do it. There's a way by integration, but I didn't
Oh, sir,
teach
I
it.
can't bother that.
I didn't teach it because I didn't think it was on the syllabus, but it's actually on the syllabus. So that was my bad. So I should have taught how to integrate partial derivatives. I didn't teach that. That's my bad.
Oh.
Yeah, that's also on the syllabus. Integral of partial derivatives.
Sir, is that a big deal anymore?
Yeah, because it's MCQ, thank God, because I would have felt awful if it was a paper two and
Today,
something
we're
like
going to be
this
sharing
came.
with you our nighttime routine and why.
Yeah, had something like this came on a paper two, I would have been terrified.
Integration of partial fractions. We don't see
Yeah,
it in my
because
textbook either, you know.
no, it's not in the textbook because I think the textbook came out 1 year before the revised syllabus. So,
Um,
so when it was the textbook, I think was published 2012 and the syllabus came 2013. And so whenever there's a change in syllabus, then sometimes the textbook is not going to have all the stuff that should be there.
okay.
Yeah.
Alright, so let's start module 2.
Yep. Module 2, this is a big repeat question again.
Is boy, right?
This is D.
Oh, D, right.
Option D. Big repeat question.
The formula for it again is xn plus 1 equals to the root, which is xn minus f prime of xn over xn, right? F of
Xn
xn minus
f of what?
f of f f prime of xn.
No, f of xn over f prime
F
of
of,
xn.
oh, okay.
Yeah.
Oh, mix it up.
Yeah, you always mix it up with pretty much the integral of ln. So this
Oh,
is what it is, yeah. Nice. So you remember the formula, that's very good. Question 17 is another repeat question. What's
to the
question
full, which
17?
given that un represents the nth term of a sequence to the full in converges. Uh, is I think we got what, A or B?
I'm asking you, you tell me.
All right, say take n to be 1,000, right? You
Yeah.
substitute n to be 1,000, and then I take the limit out x n approaches infinity.
So when you put in 1,000 here, clearly this not converging, it's not going to zero.
It's not going to zero.
It's
Okay.
not
Yeah.
getting smaller and smaller. This one is converging.
Yeah.
Now remember that we said the alternate method was to do is to take the limit as n goes to infinity, and then you have to divide through by the highest power of n. So when we
Highest
divide
power
through
of
by
n. In this case, it's n, right?
yeah, so we get 5 over n minus 3 over 2 over n minus 1, and then we're taking the limit as n goes to infinity.
Infinity. So it's going to be 0 minus 3 over 0 minus 1, which is negative 3 over negative 1, which gives you 3.
3. And that tells us the limit. That's the number that it's converging to.
Okay.
Easy question. Another repeat. Question 18 is another repeat. What's question 18?
What did they get again? 1 over 21?
1 over 21, I'm not sure. Now let's see. When u1 was 1, we get 1 minus a half. 1 minus a half is a half.
Yes, sir.
Yes, it's 1 over 21. Because then the next term going to be 1 over 3. Then the next term going to be 1 over 4. We'll continue. So if the first term is 1, the second term is a half, so that it going down to be 1 over n, or 1 over the
Yes,
nth
sir.
term. The 20th term, it's 1 over 20.
What's 1 over 20? Okay.
Yeah, 1 over 20. 20th term they want. So it's 1 over 20. Another repeat question. Easy. Question 19.
I think it's cat.
Yes, easy. Another big repeat question. What's question 20? It's another
Arithmetic.
repeat question. It's another repeat question.
1 and 3.
1 and 3. You sure about that? Check it again.
You can
One
plug
is,
in RE.
one is indeed arithmetic. That's clear. Because if you plug in R as 1, you notice that you're getting 7 plus 10 plus 13. And so it is just increasing by 3. So
All
the
right, the log
combination
of
is
3
3.
to the R plus 1 is r plus 1 times log to the base 10 of 3. So pretty much, if you plug in r equals 1,
Yeah,
so 1 plus 1 is 2, 3 squared is 9.
yeah. So when you
Then
plug
if
in
you
one,
make
you get log
r equals
9. Then what? You plug in 2, where you get
20, log of 27,
log of 27. You plug in 3, where you get log of 81.
log of 81.
So now what you're going to notice is that the log of 81 divided by the log of 27 is, so that's how you determine the common difference. The common difference, D, should be equal to the log of 27. That's
Log
now
of
the log of
27
27 over 9
minus,
minus
yes,
the
sir.
log of 9, which is the log of 27 over 9. Now you need to check if it has the same common difference
As
right
the
here
log
as
of
well.
81 over 27.
But log of 81 over 27 is indeed 27 over 9.
Yes, sir. So
And
it's
so
1 and 4.
therefore, it's 1 and 4. Not a big repeat question. The only thing they like to do is that this time they change it from 4R to 3R. That's the only difference.
Yes, sir.
But it's the same question. Question 21, not a big repeat question. What's 21?
21 is cat.
Yes, catch. Very easy question. Easy. So,
Because if a geometric sequence is convergent, right? Then it's
yeah,
going to be between 1 and negative 1.
very good. That's the common ratio. So 2x is between 1 and negative 1. And so x is between minus a half and half. Very good. Right. Question 22. What's question 22?
Question 22.
Oh, this is not a repeat question. This one is new. So let's work it out. You want the coefficient of a squared b to the fifth. So the coefficient of a squared b to the fifth is that we want the term where we're choosing from 7, we're choosing 5 a squared b to the
What's
fifth.
the formula for this again? The sum from r equals 0 to infinity of n choose r of a to the n minus r x to the r.
Yes. And we're looking at finding the
n
coefficient of the sixth term.
n choose r.
So that's all I have to do for this question. You work out 7 choose 5.
So so r equals 5.
Oh no, r equal 5 from this one. You told me the formula and you said n choose r of a to the n minus r x to the r. And so
A to the n minus.
it's always a coefficient of this one. So that's the trick, the
Okay.
second one. So let's say, what if I ask you what is the coefficient of a to the 4 b cubed? What's the coefficient of a to the 4 b cubed?
Coefficient
Yeah.
3.
No, I ask you what's the coefficient? The coefficient of this term. The coefficient of this term is going to be n choose r in front of it.
Oh, n choose r, yeah.
And so in this case, it would have been 7 choose 3. That would have been the
7.
coefficient. So right here, the coefficient is 7 choose 5, which is 21. So that's how you know how to work that question. Give me a second, I'll plug in my laptop.
Yes, sir.
All right, so yeah, that's option B. All right.
Sorry, can you give me a second?
Yeah, sure.
Yes, sir, I'm back.
Yeah. All right. By the way, Asani, you have Nikit number?
I can find his number in the Carib Studies group.
All right. So just find it and send it to me later, please.
Yes, sir.
All right. I started a WhatsApp channel, a YouTube channel. I know he's going to be interested.
Oh, you started a YouTube channel?
Yeah, I started a YouTube channel.
What's that about?
It's about sports. So I'm going to be reviewing cricket and track and field. So any major event in cricket and track and field, I review it.
Oh,
So it's just
wow.
sports. Yeah. So I'm
Must check
gonna
out that YouTube channel.
repeat.
Must check it out.
Yeah, it's called, the name of the channel is Match Officials.
Match officials. Oh,
Yeah, yeah.
so you're
I
going to
can send
officially
you
be a
I
you.
can send you a link to to my channel.
Sure.
All right.
So you're
All right, let's
officially a
continue.
YouTuber.
Yeah, let's continue. So it says the sum of the first n terms. So what's the value? What's the answer? Does this a repeat
Some of the
question?
first and 3/4.
3/4? You
Yes, sir.
sure?
'Cause the second term, the second term is when n equals 2. So it's 1
No,
minus
S2 is the sum of the first two terms, which would
first
be
two
1
terms.
a half square, which is 3/4. So the sum of the first two terms is 3/4, not the second term. The second term is
Yeah,
not 3/4.
the first two terms. That's what I should say. Yes, sir.
Yeah. So the sum of the two
So,
terms is 3/4, but the sum of the first term is a half, because when n equal 1, we get a half. And so the second term is going to be a1 plus a2. That's what gives you S2. A1 plus A2 gives you the 3/4. And
oh
so
yeah.
A2 is really a quarter. Because a quarter plus a
Oh.
half, that's what gives you 3/4. So this is the second term, a quarter.
So the sum of the first two terms is when n equals 2.
Yes.
And the sum of the first term is when n equals 1. And all I have to take into consideration is that A1, that S2 is equal to A1 plus A2.
Exactly.
Okay.
Yeah. All right. Question 24. Question 24 says, given that Sn is a summation of 1 over I minus 1 over I plus 1, find the limit as n goes to infinity. So first thing we need to do
First, you
is
have to use
rewrite
method
this.
of differences.
Yeah, what was the answer for this again? Or rewrite it. It was n over n plus 1, right?
N over n plus 1, yes, sir.
And they will find the limit as n goes to infinity of n over n plus 1. Then we have to divide through by the highest power of n to get 1 over 1 plus 1 over n. And then as n goes to infinity, the
1 over
limit,
n going to approach 0.
yeah, so the limit is just 1. Easy questions. That's another repeat question. Lots of repeat questions. So since the first, they gave 5 new questions in 2018 so far, and since then everything else has been repeated.
I mean, 2017.
Yes, 2017. Yeah. This is a repeat question. What's 29?
Okay, 1 over 36.
1 over 36, before we even do it. What was question 26? This is another repeat.
Is another repeat this? Oh,
Yeah.
12 choose 4.
Yeah. Nice. Sharp. Memory sharp. All right. Now this looks like a new question. Look what it says. The equation x cubed
X
minus
cubed
x
minus x
minus 3
minus 3 equals 0.
equals 0 has a root on the positive interval n plus 1. Find the value of n.
If it have a positive root in the interval, then you're going to take f of n and f of n plus 1.
All right. So what they're asking you to do is use IMVT.
Yes, sir.
IMVT is what they're asking. So what you're going to do is try values for n. So let n equal 1. If n equal 1, then the root we're going to have is 1, 2. The interval we're going to have is 1, 2.
Mm-hmm.
And then you find f of 1. F of 1 is going to be equal to 1 minus 1 minus 3, which is negative 3. So if f of 2 is equal to 0, if f of 2 is if f of 2 is greater than 0, then the root lies on that interval. Now f of 2 is going to be 2 cubed, which is 8, minus 2, which is 6. 6 minus 3 is 3. And so it's option A.
We check f of 2, sir.
Yeah, so we check f of 2 and we get 3 because this is 2 cubed is 8. 8 minus 2 is 6. 6 minus 3 is 3. So 1 is less than 0 and 1 is greater than 0. And so clearly the root lies on 1, 2. And that is when n is 1.
Okay.
That's an easy question. It's new, but it's very easy. They're just trying to confuse some people with the n.
Number
Question 27.
27.
That's a repeat. What's question 27?
What did we get for this again? I don't really remember, you know. Can I work it out again?
Yes, that's what we're going to do. So this question, I like it. I would put this on a paper too.
Okay.
So I have to get some more space. So they tell us that the sum from 1 to n, they tell us that that is Sn. That's Sn. Sn is the sum from 1 to n of k times k plus 1. So looking at Sn is the sum from 1 to n. All right, that's Sn. Now the next thing that they told us now is SM. SM is going to be the sum from 1 to m always. So SM is just the sum from 1 to m. SM is the sum from 1 to m of k times k plus 1. That's SM. Agreed? Agreed? Asani, there?
M is less than N.
Yeah, as we were saying now. So as I was saying, is that N is greater than M. Now look at this. So before we even do the question, just to refresh our mind of a key principle. The sum from 1 to 10, right? The sum from 1 to 10, you're adding 10 numbers. The sum from 1 to 10 is the sum from 1 to 4 plus the sum from 5 to 10. Agreed?
Mm-hmm.
All right. And so therefore, we can make a general conclusion that the sum from 1 to n is equal to the sum from 1 to some other number a plus the sum from a plus 1 to n. Agreed? You agree with this?
The sum from 1 to N is sum from 1 to A plus the sum from A plus 1 to N. Yes, sir.
Agreed. Nice.
This would
So now,
remind me of integration of definite integration.
yes. And the reason why it reminds me of integration is because integration is finding sum. It's the sum of the area. It's the sum of all the unit squares in order to generate area. So integration and summation is the same thing. If you do math further on, you're going to actually learn about it. You're going to learn about what is called Riemann sum, the left Riemann sum and the right Riemann sum. Yep. So that's integration and summation is the same thing. That's all I'm saying. But you don't need to know that for now. So right here now, so what we can then say that Sn, look at this now, Sn, which is the sum from 1 to n, is going to be equal to the sum from 1 to m plus the sum from m plus 1 to n,
To
right?
N. Okay.
Now the sum from 1 to m is Sm. And so what we have is that Sn is equal to Sm plus the sum from m plus 1 to n. And so we need to make this the subject. So subtract Sm from both sides to get Sn minus Sm is equal to sum from m plus 1 to n. That's the answer, Sn minus Sm. Very, very easy question. Sn minus Sm. Easy, soft. That's this answer, Sn minus Sm.
Okay.
Easy. All right. Question 28 is a repeat question. What's 28?
Sorry, can you scroll down?
Scroll down. Yeah. What's
Yes, sir.
28?
Dog.
Dog. Very good. Easy. soft, capital T. All right, we did 29. Question 30. Question 30 is a new question now. Very good. So this is the 8th
Can you
new
scroll up?
question on the page. Scroll up.
Oh, I see the question now.
Okay. It says it is given that the equation e to the 0.05 x plus x squared minus 3.5x is equal to 0 as an exact root on interval 0, 1. Apply the bisection interval twice and find a more accurate determination of where the root lies. So we're going to apply the bisection method. So first we need to find is what is f of 0 and what is f of 1.
That's
So f of 0, huh?
Oh, not you, sir, not you.
Yeah, so find f of 0. What we're going to get is f of 0 is e to the 0.5 times 1. E to the 0.5 is what?
1
E to the 0.5?
e to the 0.12.
Well, it's positive. I get what you're saying. Yeah, it's positive. So f of 0 is positive. So we're finding out that f of 0
Is greater than 0.
is greater than 0. So then now we need to find the interval for f of 1. F of 1 is going to be, f of 1 we'll put, wait, put in 1 now for all of this and tell me what you're getting. I'm getting, putting in 1, I'm getting, I can't work it out in my head. I'm sorry. The e is 0.5 plus 0.5 squared
0.25.
minus 3 times, minus 3.5 times 1. Wait, x is 1. E raised to the 0.5 plus 1 squared minus 3.5 times 1. That's a less than 0. So, all right, so indeed the root lies on this interval. So this one is less than 0. So now what we need to do now is find the midpoint, which is 0.5. So we need to find f of 0.5. What is f of 0.5? F of 0.5 now is 0.5 times 0.5 is 0.25. E raised to the 0.25 plus 0.2 e plus 0.5 now square minus 3.5 times 0.5. I'm getting it's less than 0. So f of 0.5 is less than 0. So if it is less than 0,
between 0 and 0.5.
all right, so the root falls between 0 and 0.5. So now that's one bisection. We need to do another bisection. So we do another bisection, and that would be, we need to find what is
.25. F of
yes, f
0.25.
of 0.25. I guarantee f of 0.25 is going to be greater than 0. I just know. So 0.25, so e raised to the 0.5 times 0.25 plus 0.25 square minus 3.5 times 0.25. That's greater than 0. Since it's greater than 0, then the root lies between 0.25 and 0.5.
Oh, right, 0.5, right, 0.5.
So that's the range we'll narrow it down to. That's option D. Easy question. Soft. And now finish module 1 and module 2. And now we'll have a glimpse at module 3. Module 3, the first question, that's a repeat. What's 31?
Boy.
Yeah, boy is right. Easy. Soft. All right. Question 32. Question 32 is another big repeat question. That's question 32.
Dog.
Repeat?
Dog.
You sure?
Sure.
Yeah, that's right. Repeat. That's easy. Soft. Question 33. Another repeat question. Oh my God, 2017, they're so lucky. What's question
0.25.
0.25, that was right.
Alright,
Imagine.
so since it's a conditional probability, the probability that L occurs given K is
The
given
probability L
of L given K
given K. That's
is
equal to,
L intersect K complement,
which is 0.15. That's L intersect K.
L intersect K over the probability of K.
The probability of K is all of this, which is 0.6. A lot of person get mixed up with this question to put 0.33. But thus this part is K only and not K.
K only is 0.45 plus 0.15.
Yeah. Easy question. So they repeat. Only 8 fresh questions so far. Question 34. That's a repeat question.
Question 34, the determinant of the matrix. It's gonna be 3 times 3, -2, 5, and 4.
3 times 3, -2, 5, and 4. Yeah.
Plus 1
Plus 1
times 2, -2,
2, -2,
0 and 4,
0 and 4,
plus 5
plus 5
times 3, no, 2, 3,
2, 3,
0 and 5.
0 and 5. That's equal to, so work it out, we're getting 3 times. This looks like 12 plus 10.
12 minus 10, which is
Minus
2.
10 or
So
plus 10? I say plus 10.
plus 10.
Which is 22.
So, oh, yes, sir.
Plus 1 times, this is now 8.
8 plus 2, 10.
8 plus 2.
8 minus -2, which is 8 plus 2.
No, it's 8 minus 0. 2 times 4 is 8.
Oh,
Yeah. Then we have plus 5 times
10.
5 times
5
10.
times 10.
Yep, so we get 50 plus 8, 58 plus 66, that's 124.
124.
Easy. Soft. All right, question 35. Question 35.
Alright, so if it's mutually exclusive, then that means the intersection is 0. Right?
Yeah.
So what are the probability of a sample space?
All right, so what you know
The
about
probability of P plus the probability of The probability of Q plus the probability of R must equal 1.
Yes, that's exactly what I was going to say. The universal set has a probability of 1. Then tell you that you have S, Q, and R, and none of them intersect. And so if they tell you that 1 is 0.6, they tell you that 1 is 0.3, then what the other one must be? In order for it to sum to be 1. In order for it to sum to be 1, it has to be 0.1. All right, question 36. Question 36.
Dog.
Easy, right? Easy question. Dog. Nice. Question 37 is another repeat. What's question 37?
0.
Question 37 is 0.
A.
Why is it 0?
Because the first equation is not a scalar multiple of the third one.
Exactly, very good. So therefore, what happened to the system?
It is inconsistent.
All right, yes, the system is indeed inconsistent. Very good. Nice, soft. All right, question 38. This is another repeat. Talk to me. What's question 38?
Dog.
Yes, question 38 is dog. Very good. Why is it dog?
Alright, first things first, it's permutation using repetition and what else?
I want you to tell me first and foremost that the permutation or the possible arrangement for when R is together is 7 factorial times 3. And so then now the arrangement of when they're not together is going to be the total arrangement minus
Total arrangement minus when they're together.
Yes, that's what I wanted to hear. Total arrangement minus when they're together. All right, very good. Question 39. It says the planes represented by the equations 2x plus y minus z plus x plus y plus z and 3x minus 2y minus z equal 2. It says which of the following is true? How are you going to know if it's true? Repeat.
I think it's inconsistent, you know, because they don't look scalar multiples of one another.
They don't necessarily have to be a scalar multiple of one another. When I say scalar multiple of one another, is that look at this now. This question is all of them are definitely a multiple of each other, right? But look at the key thing. If you were to multiply this one by 3, when I say the system is inconsistent, think about it this way. If I tell you that x plus y equal 2, right? Let's say I tell you this. I tell you x plus y equal 2. If I tell you x plus y equal 2, and then I tell you that 2x plus 2y equals 0, that make no sense?
No.
No, because then if x plus y equal 2, then 2x plus y, 2 times x plus y, which is 2x plus 2y, should be 4, right?
Yes, sir.
By following natural laws of mathematics, yeah. So if you were to multiply this first equation by 3 at the top, you should get 6x plus 9y plus 6z equal negative 15. But that one you're not give negative 15, right?
Mm-hmm.
I give something different, and so therefore that's why this system is inconsistent, because it makes no sense. So that's what we mean also the system inconsistent. It don't make no sense. Now this one now, we don't know if the next question makes sense. So we have to go find out. So it gives me 2x plus y minus z equal 4, x plus y plus z equal 1, and 3x minus 2y minus z equal 2. The best way to find out if the system is consistent or inconsistent is row reduction. And I remember when we looked at it, I said if you have 0, 0, 0, 0, this one would tell you that the system has infinitely many solutions and is consistent. And if I tell you if you have 0, 0, 0 in the last row, and it's equal to some number r, then this one is inconsistent and has 0 solution.
Mm-hmm. So it's no solution.
This one is infinitely many solution. And this one would be no solution. And so now let's check it out. We don't know which one it's going to be, right? So I'm gonna have to write down the matrix. We're gonna have to write down the matrix. Give me a second.
Mm-hmm.
Yeah. All right. Sorry about that. So let's continue. So if we were to write this in matrix form, in augmented matrix, tell me what this would be.
2, 1, negative 1.
All right, 2, 1, 2, 1, negative 1, 2, 1, negative 1. And I'm just going to put the augment and write 4.
Mm-hmm.
What's the next one going to be?
1, straight 1 across the board.
Straight 1 across the row, not across the board.
The row, sir.
Yeah, 1, 1, 1. All right, what's the next one going to be?
3, negative 2, negative 1. And behind the augmented line, you can have 2.
All right, very good. So 3, negative 1. What did you say? Negative 2, negative 1. Negative 2, negative 1. And then we said a number, I don't remember that number, 2. All right, so let's row reduce now. So what we're going to do is multiply row 2 by, so look what I'm going to do. I'm just going to multiply row 2 by 2. Right, so I'm not
Yes,
even,
sir.
yes, I change everything to 2, 2, 2. So it's the same thing, 2, 2, 2, 2. Then now I'm just going to go row 1 minus row 2. Row 1 minus row 2 is going to then give me row 1 minus row 2. Row 1 minus row 2 is, that's 0. Let me write down what row 1 would be. 2, 1, minus 1, 4. So I get my 0, which I need. 1 minus 2 is negative 1. Negative 1 minus 2 is negative 3. 4 minus 2 is 2. Then I need to get 0. I need to get now 0 right here. So now I'm going to say 3. I'm going to say 3 row 1 minus 2 row 3. So when I do that now, what I'm going to get is 3 row 1 is 6. 6 minus 6 is 0. 3 row 1 is 3 times 1 is 3. 3 minus 2 times minus 2 is, so 3 minus 2 times 2. I use my calculator. 3 times 1, just to not make any mistake, minus 2 times negative 2. I'm getting 7. I use my calculator just to make sure it's no mistake. Then negative 3 minus minus 1. So negative 3 minus 1. So 3 times negative 1 minus 2 times negative 1, that's negative 1. So I just use my calculator to make sure. And then 3 times 4 is 12. And 12 minus 4 is 8. So I'm almost finished. Now I need to use row 2 to get a 0 in row 3 right here. So what I'm going to do is multiply by 7. So I'm going to say 7 row 2 minus row 3 to get 2, 1, negative 1, 4, 0, negative 1, negative 3, 2, and then 7 of this minus, that's still 0. 7 of this plus this is 0. 7 of this now. So 7 times minus 3. 7 times minus 3 is minus 21. Plus minus 1, that's minus 22. And then 7 times 2 is 14. 14 plus 8 is 22. Now look what this is telling us. What this is telling us then is that z is equal to minus 1. And so it indeed has a unique solution, because from we find z, we can find y and we can find x. So it has a unique solution. And so the system is indeed consistent. That's clear now?
Mm-hmm.
Repeat.
So it's no solution?
It has unique solution. So this is not the case. Yeah, so this is the case where it has unique. This is the last, so we're talking about the last column. So if you have 0, 0, r equal x, then it has unique solution. Yeah. That's when it has unique solution. So this question, it has unique solution. All right. So that is unique solution. That's option 3. Asani, dear. And it's also not parallel. C.
Sir.
Yeah.
When it's not parallel, what has to be the condition?
So it's just like regular equations of line. So let's say y equal mx plus c. Let's say y equal 2x plus 5. Give me a line that's parallel to this. Then y is equal to maybe 2x plus 7, right? They have the same gradient, don't it? That's parallel lines, right?
Because they have the same gradient.
Yes, parallel line is when they have same gradient. So let's write this in standard form. For example, this can be written as y minus 2x equal 5 and y minus 2x equals 7. So those two would be parallel.
But remember, remember section of the future, the funny belt, the small belt there? It had gear diarrhea. Yeah. But to me, used to to me.
Yeah. Let's have a look at these. Look at this question now. None of these equations or none of these lines are multiple of each other. So let's go back to the next page. I'm going to show you something. This and this are parallel. 2x plus 3y plus 2z. If you multiply it by 2, you get 4x plus 6y plus 4z. So
Yes, sir.
These lines are parallel. So 1, 2, 3, all of these lines are parallel. Now, if you're to look at these lines, none of them are scalar multiple of each other. And so they can't be parallel. That makes sense? Yeah, so that's how you tell if they're parallel. So they are parallel if they are scalar multiple of each other.
Well, just like vectors.
Just like vectors. All right. Yes, that's very good. Think of vectors. Very good. And so these are not parallel. And it also has a unique solution because we were able to find a value for z, a value for y, and a value for x. So it has unique solution. That is option C. Right? Question 40. What's question? Big repeat question. What's question 40?
Two coins and a die with faces numbered 1 to 6 are thrown together once. Assuming that the die and coins are fair, the probability of containing two heads and a number less than
4. Yeah.
It'll be the probability of h times n, which is less than 4.
Yeah.
But
Which
what is
is
h though, sir?
the probability of h is what? A half. Probability of
By
getting
half though.
head. Why is it half? Because you only have two options, head or tail. So if I flip, so if I have a coin, it's either there's a 50% chance to get head or a 50% chance to get tail.
Okay. Makes
And
sense.
times it by the next coin, 50% chance of getting head.
Right.
Then what's the chance of me getting a number that is less than 4? There are 3 numbers less than 4 out of 6. It's a half times 3 over 6, which is 1 over.
That's what I was gonna repeat a while ago. You have ginger.
That's option C.
By the way, where you get the 3 over 6 from again?
3 over 6. So this is how many numbers are less than 4? Only 3 numbers, 1, 2, and 3. So there are three possible numbers that you could choose that is less than 4. And it's out of 6 numbers.
Okay. And
so that's question 40. Question 41. Look at it. Just tell me. It's a repeat.
A.
So, you sure? Both are red. 4 out of 10, 3 over 9. Yes, A. Very good. Nice. Question 42. Question 42.
Are the peppermint spaghetti?
Question 42.
42. So you know I'm gonna have to work out. I think it's dog.
Yes, it's dog.
But the
So
roots
we
are
had
real
found that it had complex root. Yeah, so we had to work out what is lambda. And lambda is equal to minus b, which is minus 6, plus or minus the square root of b squared, which is 36, minus 4ac, which is
all over 2A.
minus 50, 36 minus 50 over 2a, which is 2. And so this part is giving us some complex number. And so lambda is working out to be some alpha plus or minus.
Man, I like them African through there. Just more
Beta
no
I.
control. Number 43.
Yeah. Oh, Hassan, is you always watching the African shows?
Well, actually, my mom said.
Oh, I understand. I always hear it. So it's a Wednesday thing to watch African shows on Wednesday.
I don't know, you know, sir.
Because everyday thing.
Everyday thing for her, sir.
Okay. No worries about it. Now it asks for the integrating factor. Integrating factor.
No, what did I get for this again?
Integrating factor is e
to the integral of 2 over x.
2 over x.
And if I integrate 2 over x, you're going to get the ln of
integrate 2 over x, you get e to the ln. So it's actually 2 ln x.
2 ln x, yeah.
And 2 ln x is really e
to the ln of x squared, which is x squared, so yeah. So for the choice C.
X squared, yeah, that's C. So only 9 fresh questions came on this paper. Everything is repeat. You would love that to happen, right?
I would love that to happen, yes.
35 repeat question and only 10 fresh question. That would be great. That way I would show that everyone do really well. Asani, also, it's good to sometime, just motivate a classmate. So it's good to call a classmate, check up on a classmate. So you can always call a friend. So call maybe Christoph, call Jumaine, call Javon, call Joans. Just check up on your classmate. Not just for maths, but for every subject. Always check up on your classmate.
Okay.
Yeah, trust me, it's worth it. And in the long run, you're gonna find out that you go to university, you leave university. At the end of the day, you see friends in high school, especially your friends now in sixth form, are gonna be your closest friends for life.
Don't think so.
Well, I can tell you pretty much from experience. So let me tell you from now, whether you go to university here or abroad, right? What happened is that when you go to university, persons are so focused on schoolwork and self-development and starting a career that rarely you build true friendship in university. I can
True
tell you that.
friendship actually starts in university. Yeah, I understand, but I want to see some new faces.
Yeah, trust me, you're gonna see some new faces. Don't get me wrong, and you're gonna make new friends, but those friends aren't necessarily gonna know you for who you are. You're going to meet persons that they're going to say, "Oh, Hassan, help me with this," or you might know somebody that you say, "Help me with this," because 50% of the time you're gonna spend doing work, right? And majority of those times you're gonna spend time around people, but it's more to do schoolwork. And probably the next
Mm-hmm.
50% of your time you spend is maybe with your girlfriend or you know,
Mm-hmm.
or entanglement. I'm just saying. So yeah, so pretty much your closest friend's gonna be from right here, high school.
I don't think I'm gonna experience that, sir. Because trust me,
That's true. Everyone has different experiences. I'm just telling you from what
from
I've
years.
seen.
Okay,
No, I didn't say
that
from my experience. I was just saying from what
overall.
I've seen. Yes, from what I've seen.
Okay.
Trust me, I've met some very good friends at university. Yeah.
Okay. So yeah, do you
But
finish your bachelor's degree, sir?
yes, I'm finished. So just a small few though. Just a small. All
So
right.
so how did it? So how do they do this grading system at UE?
So the thing about you is that they have a grading system where you don't you're not gonna get a report card where you're gonna say, oh, you get 88 and you get 95. What you're gonna see is a score system, and how they do it is that 90 to 100, that's 4.3. That's the highest you can get. 4.3.
Yeah, I think I see it online already.
Yeah, and then from 80 to 89 is 4.0. From 75 to 79, I think it's 3.7, and so on. And so let's say you do, it depends on how many courses you do. If you do 6 courses, and let's say for 5 courses you get 3.7, and one course you get 4.3, and it would be the 3.7 plus 3.7 plus 3.7 plus 3.7 plus 3.7 plus 4.3 divided by 6. That would work out to be 3.88, 3.76, I believe, or 3.79,
And that's
something
my
like that.
and that overall would be a what?
That would be a very good GPA. That would be what's
Oh, that works out
considered.
to be a GPA.
Yes, that would work out to be a GPA. And when
Okay,
your GPA
so
is above 3.6, they say you graduate with honors.
yeah,
Yeah, so that's honors. When your GPA is between, I think, 3.3, from 3.3 to 3.6, that's just your regular bachelor degree, right? And then anything in the two, you're just graduating. So I don't know how people just want to graduate and just get 2.0. 2.0 is the pass mark of 50. And I don't know some
okay,
persons graduate with 2.0.
that's a
Yeah,
pass mark. 50.
yeah, that's a
I'm sorry
pass
here.
mark. But don't ever aim for pass mark.
I know, sir.
Yeah, the only time I aimed for pass mark was for an English course I had to do, and English is
Carib said.
not, no, not Caribset. English is not, it's called critical reading and writing. You're gonna have to do it.
Oh, that
Yeah, it's the worst thing ever. Well, for me, I just
I
managed to
can tell.
scrape. I just
I
managed to
can tell
scrape and
from
pass
your
that one. I got 51 in that course. That's my lowest grade ever. Yeah, scrape and pass that one. Scrape, only just. And I had gotten help from Miss Brown with one of my assignments. So you know, if I didn't get help, I probably wouldn't have passed. So It's
Wait,
very
so
difficult.
say there's 6 courses, sir. So you have exams for those 6 courses, right?
It depends. Some courses don't have exams. Some courses might only be assignment that you have to take home and do. Some courses, it's only exam, so you don't get no assignment throughout the year, but one big exam. And that's a disadvantage with university because let's say you're just going to class from September to November and you're not getting any practice tests. And then all of a sudden, December, you just have one final test to do.
But would you have class for it?
Yeah, you
No,
have
no, no,
class.
no.
Yeah, you have class. But the thing is, when you're just going to class and you're never getting any assignment, it's difficult to just go and prepare.
It's just the assignment I'm really thinking about now.
Yeah. Well, let's get back to this and finish. Don't worry about university for now. Worry about your exam tomorrow, your Caribbean studies, your easy distinction. So let's hurry up and finish so you can get back to finalizing.
Yes, sir.
So right here we just group X together. So we have 1 over,
Oh, say the separation of variables here.
yeah. So talk to me.
So it's dy equals to dy by cosine square y
Yeah.
equals to 2x dx.
1 over cosine square y. Why that cosine square look like that?
Mm-hmm.
So 1 over cosine square y dy.
Is times dy.
Yeah. And that's equal to 2x dx.
Yes, sir. And then integrate both sides.
They integrate both sides. Integrate 1 over cos square y. What you get?
All right, 1 over cos square is secant square y. And if you integrate secant square y, you get tan y.
Tan y. So you get tan y
Tan
is
y
equal to
equals to x squared.
integrate 2x, you get
X
x
squared plus
squared,
c.
x squared plus c. So clearly it's only option A.
Mm-hmm. Yeah.
And therefore your c in this case is 3/4.
That is when you're finding the constant.
Yeah, because we could find a constant right here by putting in when y is pi by 4.
Pi by
X is
4,
half.
tan is, the tan of pi by 4 is 1.
Yeah, so we get 1 is equal to a half
A
square,
quarter.
a quarter, and so c must be 3/4.
Yes, sir.
All right, question 45. Finally, what does this statement tell you? The matrix A represents a system of linear equations after some.
Wait. The solution is unique.
That's unique.
I'm positive, sir.
Look at the bottom row. 0x plus 0y plus
0.
0z.
Oh, infinitely many solutions.
Tell me what the last
No.
row is saying.
0. All right.
What's the last row saying?
It's you have no x, no y, you have no z values, right, sir?
Yeah.
But here in the augmented line, you have 2.
So it equals 2. So nothing plus nothing plus nothing give 2. That makes sense?
No solution?
No solution. So when it don't make sense, it's no solution. The only time it's infinitely many solution is if you have 0x plus 0y plus 0z equals 0. Now that makes sense, but that means you have a million solution. Because if I have 0x
Sir, what
plus,
if the 2 wasn't there, sir? I have a 0. That's infinitely many solutions.
yes, because x could have been 1, y could have been 1, z could have been 1. But 0 plus times 1 plus 0 times 1 plus 0 times 1 is still 0. Then x could have been some of them.
What
Yeah.
if you have 0, 0, 3 augmented line? I have 2.
Then that is unique solution.
Unique, all right.
Yeah.
So that be 3z in this case equal 2.
Yes. That's what we looked at right here, the different cases. unique. 0, 0, RS. So RZ equal S. 0x plus 0y plus 0z equals 0. And 0 plus 0 plus 0 equal R. Those are the three cases. All right. So that's 2017. So next week we're gonna have to go through 2018 and then the other one
And
2019.
2019.
Yeah. So we won't bother
Yes,
look
sir.
at the specimen paper.
What specimen paper is that?
I wanted to look at the specimen paper, the paper that we got for mock exam.
Oh, that
Yeah.
paper.
More than likely none of those will come on an exam, but just wanted to go through it. I
That
really
can
hope,
be.
yeah, I hope that the weekend, I think the exam, remember, is a Monday. And I
The 27th.
want the Sunday or the Saturday. Yes. We have exam the 27th. I want the Saturday before the exam. Everybody in our class, I want us to have one last meeting. And we'll just talk about everything. We'll talk about the entire sets of papers. We'll just talk about everything. Make sure everybody just go in and fully ready. I want everybody to can even think about getting full marks if questions do repeat.
Mm-hmm. Yes,
All
sir.
right. Yeah. All right. So
Yes,
just go ahead and finish prepare for Caribbean studies and all the best tomorrow. All
yes,
right.
sir. But back to what I was saying about the grading system at UE.
Yeah. What about it?
Oh, yes, sir. 4.3 is the highest, and the lowest passing grade is a 2.0.
Yeah. So anybody below that, they're failing.
They fail. So just get a class, they don't come back, or they can remove them from that faculty and put them in some other faculty that the student desire.
No, that's not the case. If you fail twice in a year, then you have to take
Twice?
a yes. So let's say in the first term your GPA is less than 2.0, then you get a warning. After you get the warning, if you get below 2.0 again, what they do is say you need a year break and come try again. So persons take the year break and come back and do the same thing, and then they pass. In that year break, you can work, you can study, whatever you want to do.
Okay.
Yeah, so but it's never nice to spend so much money, and
Yeah, for real, sir. That's that not ever reach me.
yeah, so that's what happened to some person. But those are slow learners. Right? So you won't have any of that to worry about.
Yes, sir.
Yeah. All right. So just definitely let me know how the exam is tomorrow. And also when you get some time, find out Nikit's number for me.
Could I be sometime after tomorrow?
Yeah, tomorrow.
Anytime tomorrow,
Yeah.
yes, sir.
Yeah. Focus on the exam and then send me his number tomorrow. And I'm gonna send you my channel tomorrow. You can look at it tomorrow.
Yes, sir.
All right.
So have
All
a
right.
good night.
Yeah. So take care.
Yes, sir.
Yeah.